issue or without any error. So first step for errors is we have to make sure the input that we give already meet the requirement by the software. So in this case, Aspen Hysys will let you know either is there any missing informations. Okay, you can look at the color on the folders, on the file folders on the component list and also fruit package. It now is red colors. This means that folders or that sections has missing information. So we need to give our input to these sections, especially on the component list and fruit package. Okay, so our goal here is to make sure all input required by the software has been fulfilled. If you still can recall what we learned on lectures 5, for Aspen Hysys, there are three important steps when we're defining for property. Okay, so first step is always the components, means what kind of material that we use. So first step is define what material that we use. Second step is defining the fruit package. Basically, is a thermodynamic property. We have to define what kind of equation of state that we use to calculate for thermodynamic property, so that from the thermodynamic calculations we can find the property of fruit. That's why it's called fruit package. Third step will be defining for the reactions. Okay, so once you're done with all three inputs, materials, fruit package, and reactions, then only you can move forwards to simulations. Okay, simulations basically is the sections. It's a flow sheet. Means it's the empty flow sheet. It's empty platform for you to draw the PFD. Okay, process flow diagram. So before we move on to simulations on the property side, under component list, you can click add. Okay, click add means in these sections we're gonna add the material that exists in our question set. So we can type the names or the formula on this column to filter out the material that we want from the database. Okay, so there are three options here. We can search by simulation's name. We also can search by its full name. We can search it by formulas. Okay, this is up to your preference. See which one you want to search for. For my case, I prefer from formula, because I do know what is the formula of my materials. Let's say for in class 5, we have 4 components, means we have 4 different species. First species is hydrogen chloride, second is ethylene, third one is ethyl chloride, fourth one is nitrogen. So you can type HCl, the formulas for hydrogen chloride. Okay, once you type HCl, then you can double left click on the first options. Once you double left click, you can see HCl has been selected to your left hand side, the component list on the left hand side. Okay, so if you're able to see HCl appear on your left hand side, means you already successfully select HCl as one of the components or as one of the species exists in your system. Okay, second one will be your ethylene, which is C2H4. Okay, double click on that, ethylene. Do the same for the third component and fourth components, which is C2H5Cl. And also nitrogens. Okay, it's quite easy. This is how you define the material exits or that you can find in the system or in your simulations file. So once you define the material that we have, then you can check on your left hand side. The folder now, the color has been turned from red colors into blue color. Okay, it means component list we already completed. At least the software know the input is there. Okay, so we can move on to the next input, which is on the fruit package. Fruit package, you click add. Once you click add, you can see on this database there are lots of options for you to choose from. Okay, on the property package selections, there are a lot of options. Then which one to pick is, of course, first one is refer to the questions. If the questions already specify what type of package you should select, like in class 5, they already define the fruit package as Pink Robinsons. So search through the database, select Pink Robinsons. Once you select Pink Robinsons, you can see the status bar at the bottom there is turned into green color with the OK sign. Okay, it means you already defined for your fruit package. Okay, in this case we're gonna use Pink Robinsons. Pink Robinsons basically is a name for the equations that calculate for equation of state. Okay, so there are many methods appear for you to calculate the equation of state. Equation of state, EOS, normally is the equations for us to calculate those important thermodynamic property. What kind of property that we can calculate, like density, viscosity, enthalpy, entropy, given free energy, and many more. Why we need to calculate that? Because we need this property to solve the mass balance and also to solve for the energy balance. Okay, so what fruit package did is to define what equations that we're referring to, so that we can use the equation to calculate for all those important thermodynamic property. So with this property, then only we can calculate the mass balance and also energy balance. Okay, so this is easy if the question already specified what type of fruit package we should use. If the question never specified what type of fruit package you use, then you can select method assistant on top. Okay, under home ribbons, you can see here we have one option called method assistant, and you can click on method assistant. Basically, it's kind of like a help tool to help you to search which fruit package is suitable for your system. Okay, so basically you just need to answer the questions. So like this case, start by selecting all the following options. Maybe specified by component type, and then what type of system do you have? Maybe hydrocarbons, and then you answer the question yes, no, it's up to you. And once you select, once you answer all the questions, then the help engines will suggest what type of fruit package is suitable for your case. In this case, they suggest 3. Charles, Pink Robinson, and SRK. So either one should be fine. So you can use either one as your fruit package. Understand? So there are 2 options for you to select the equation of state. One is referring to the questions. If the question is specified, then stick with the fruit package set by the questions. If the question never mentions, then you need to click on the method assistant to search which fruit package is suitable for your case. Okay, so there are 2 ways of doing it. So once you're done with the fruit package, we can proceed with the reactions. Okay, remember the third step is we have to define for reactions. So click on the reactions and click add. Okay, and then add reactions. If you look for this reactions message pop up, there are 5 different type of reactions: conversions, equilibriums, heterogeneous catalytics, kinetics, and simple rate. Okay, to me, I can categorize this as only 3 types of reactions, which is conversions, equilibriums, and kinetics. Okay, I categorize heterogeneous catalytics, kinetics, and simple rate in the same category of kinetics reactions. Okay, it doesn't matter if it's heterogeneous catalytics or kinetic or simple rate. These 3 requires you to define for the rate constant, means the small k value, okay, rate constant, and also the activation energy. That's why it belongs to type of kinetic reactions. Okay, for conversion reactions, basically you define the conversion conversion rate means normally it's a fixed value. So you define how many percent have been converted. Then the software will help you to calculate the balance of it. Okay, so conversion type reactions is we define a constant value for the conversion rate. For the equilibrium reactions, basically we define the equilibrium constant. The not small letter of K is capital K. Okay, we are defining for the equilibrium constant. So you can at this point you can select what type of reaction do you have. For in class 5 is the question state that we have to use conversions. So click on conversions and then add reactions. When you click add reactions, you should be able to see you have reaction 1 labeled as RXN1 appears on your message bar. And then you can double click on reactions 1, double left click on reaction 1, then will lead you to another window, which is the detail of reactions 1. At this window box or message box, you will need to key in the information required to define for these stoichiometric reactions. Okay, so on the stoichiometric informations, you have to define for the stoichiometric reactions. So if you're referring back to the questions of in class 5, at the beginning of in class 5, they give you the chemical reactions, which is 1 mole of ethylene react with 1 mole of HCl. Will give you 1 mole of products. Okay, the product is C2H5Cl, which in this case the symbol is ClC2. Okay, so the component accessed in your chemical reactions is ethylene, HCl, and also your product. In this case, the symbol they use is ClC2. Select all the chemical components or species that involved in your reactions. Okay. By right, you should have another species acid in your symbol, which is nitrogen. Nitrogen is an inert gas. It's not going to take part in your reactions. That's why when we defining for reactions, we will exclude it out. Okay, we are excluding nitrogens in your reaction in reaction definitions. Okay. So once you select the component axis in your reactions, next is you have to define for the stoichiometric coefficients. Basically, it's the coefficients of the stoichiometric reactions. Okay. So in this case, you have to be careful with the sign. Either it's negative or positive. If we reactants, then we should put a negative sign. If it's the product, then we need to put a positive sign. Okay. So according to the reactions given on the questions in class 5, 1 mole ethylene react with 1 mole HCl. So ethylene and HCl should be your reactants. So should be a negative sign. So should be -1, -1. So then we'll give you 1 mole product, which is C2H5Cl. In this case, the symbol is ClC2. So you should put 1. The sign is positive. So we have -1, -1, and +1. Okay, that is your stoichiometric coefficient for your reactions. Then on your right hand side, you have to define for your base components. Normally, base component is your limiting components. Okay, and then reaction phase is what kind of reaction phase that exists. Sometimes it's maybe liquid or vapors, or you have both phase exist, then you can say overall. Okay. Then C0, C1, and C2 is sections for you define for the rate of conversions, and you can go through on the question sets as well. The questions state that the conversion should be equal to 90%. So type 90 as C0. Okay. Then how about C1 and C2? And then in Hysys, they calculate the conversions based on the equations given below. Conversions bracket percentage equal to C0 plus C1 times T plus C2 times T to the power 2. So basically, this is the equation they use to calculate for your conversions. And then according to questions given in class 5, they only give you C naught value, they did not give you the value of C1 and C2. So it means like the conversion rate that you have is independence of the effects of temperature. So that's why C1, C2 are 0. So you define C1, C2 as 0. Okay. Just now, if you did not type 0 for C1 and C2, or leave it at empty, then I think by default it should be equal to 0. But to avoid any confusions, it will be better for you to type 0 for C1 and C2. If the questions never state what is the coefficient for C1 and C2. Okay, so there you have it. This is how we define reactions for conversion reactions. Okay, we're going to see the example of heterogenic catalysis and kinetics, I think, in the following in-class practice. So in class 5 is to deal with conversion reactions. Okay, maybe in class 6, 7 or 8, we're going to deal with heterogenic catalytic reactions and also kinetic reactions. Okay, then you can close. You can come back to the previous manual on reactions. You can see we still have a yellow warning here. It mentions not attached to FP. FP normally here stands for fluid package. This means the reaction that you define is yet to attach to any fluid package. Okay, so you need to click add to FP. Okay, the button next to it, click next add to FP, and then in this file we only define for one fluid package with Pink Robinsons. So click on Pink Robinson and click on add set to fluid package. When you click that, then the message box here, the status box will be turned into green colors. Okay, named at radius and independence. Okay, so once you're done with that, then you can see on your left hand side, all folders color has been turned into blue colors. Means you already defines all the information required for the property. Okay, what is the meaning and why we need to do the step add to fluid package? The main reasons is just now the reaction that we define is we only define for the stoichiometry and also the overall conversions. But when the software want to calculate for the conversions, they need additional information like the density, the viscosity, this kind of property. That's why we need to attach to the fluid package so that they can calculate the reactions based on the equation of state that we define. So that from the equation of state, they can calculate the density, viscosity, or any thermodynamic properties they require to calculate the reactions. Okay, so attach to fluid package is very important step. So make sure you do that whenever you're defining for reactions. Okay, of course you can define more than one reactions here. You can do you can add new reactions, reaction 2, reaction 3, 4, and 5, or even more. Then you can attach to different fluid package. Means you can calculate the reactions based on different equation of state. Means if you based on different equation of state, then it's, means the thermodynamic property that is calculated on you might have a different value. Okay, that's why you're gonna understand what type of fluid package is suitable for your system or suitable for your components. Okay, either your component is belong to non-polar or polar materials. Okay, that is requires knowledge or your fundamental knowledge on equation of state. Okay, see which principle is suitable for what type of materials. Of course, you can still stick with the method assistant. It's an easier way. Okay, it's good to know how method assistant help you to make your decisions. Okay, so it means we have to identify what is the features of Robinsons, and what is the features of NRTL, and maybe what is the features of SRK. Okay, so if you understand that, then maybe it's good when you are answering the questions in discussion, maybe during your test too, they ask you why why pick Pink Robinsons as your free package, then you can answer. Okay. So yeah, you can go to the lectures, then you check what is the features of Pink Robinsons, what is the features of SRK, and then what is the features of NRTL. Okay. One is for ideal, one is for non-polar, one is for polar. So when you define for that, you can move on to the next step on the simulations. When you click on simulations, you will see here your empty space. Normally we call this empty space a flow sheet. Means it's a platform for you to draw your PFD, process flow diagram. Okay. Then you have this model palette appear. So this normally here you can select the unit operation that you have for your for your process. Okay. If you put your cursor on tops on the symbol, you can see we have mixers, we have tea, we have heaters, coolers, heat exchangers, pump, and many more. There are many unit operations that you can select through Aspen Hysys. Okay. Then we move on to step 4, adding and specifying the feed stream. Okay, so for in class 5, the first thing that we define is the stream. So you see the arrow. There's blue arrow and red arrow. Blue arrow is material stream. Red arrow is for energy stream. So right now we are defining for the material stream. So we click on the material stream and then click it on the empty space on the flow sheet. Okay. When you click on that, you can see the color here is in green. Okay. Not in dark blue color. If it's in green colors means they are still have this symbol having a missing information. Means it's require input so that it can run smoothly. Okay, you can double click on that. Once you double click on the feed stream, you can see here there's a lot of empty space. That's why you can see empty. Means you need to define the information there before the feed streams is fully defined, or you can use it for your calculations. Okay, so check from the question set. We can rename the stream name to feed. Okay, rename to feed, and then according to the questions given on class 5s, the temperature is 25 degrees Celsius. The pressure is 1 atmosphere. And the default units in here, they stay as kilopascal, but you can change the unit over here. Since the dimension is 1 atmosphere, then you can select atmosphere. Then the software will automatically do a unit conversion for you, convert 1 atmosphere to kilopascal. So in this case, 101.3 kilopascal. Okay? So Hysys is quite user-friendly in terms of unit conversions. And then the next will be the molar flow. The unit here is kilomole per hour, and the same units as what's given on the question set. That's why you can directly type hundreds. So 100 kilomole per hour. The next step is to define for the compositions. Okay, click on the compositions there. Then you check at the beginning of the questions, the PFD given on the questions. They already state the compositions of your feed in. For HCl, that is about 50% is HCl, so it's 0.5. Ethylene is 48%, so that's why it's 0.48. There's no product at feed in, so it's 0. Nitrogen is just 2%, so it's 0.02. When you type in all the fractional compositions of your feed in, then you can confirm on the total value at bottom, is it equal to 1 or not. If equal to 1, then you have a high confidence like your fractional composition is correct. Okay. When you define for that, then you can see the color of your feed stream now has been turned into dark blue color, from green into dark blue colors. So it means you already successfully defined this feed stream. Once you're done with the feed stream, then you can move forwards to define for the next unit operations. So the next unit operation will be your mixer. Okay. If you know the names of the symbol used in Hysys, you can directly type the name of the unit operations that you have. Let's say mixer. You can type mixer on this search column, and then the software will automatically help you to filter out the unit operations that you want. Okay, so you can click on mixer and then paste it on your flow sheet. Okay, so when you're choosing the unit operations that you want, either you search the name of the unit operations, or you search it one by one through the symbol. Okay, it's quite tedious. Okay, you only need to search manually one by one if you do not know what is the names used in Hysys to define for the unit operations. Okay, all the equipment. So you can see here the mixer still in red in colors, means it yet to be fully defined. So you can double click on that. Once you double click on that, there are few information that requires you to fill in. First one, you can change the name to M1. Okay, and then the inlet here should be R * and feed. So select feed as your inlet. Okay, once you select feed as your inlet, you can see the connections is automatically connected from feed to the mixers. Okay, and then the question asks you define for R *, but in this case we define later on instead of defining here. So, and then the outlet should be S1. You can type S1 as your outlet. Okay, okay. Once you're done keying the information required for mixer, then you can see the mixer now the color has been turned from red color into dark blue color. Okay, then you define for your mixers. Then we move on for defining the next unit operations, which is conversion reactor. Then you can search conversion reactor, and then click it, paste it on your flow sheet. Now you can see it's still red in color, means there's a lot of missing information. So double click on the conversion reactors. There are many informations that we need to define over here. So first one, start with the inlet and outlet first. So our inlet is S1, and the vapor outlet is S2. At this case, there's no vapor outlets. That's why you have to define yourself. So we type S2 and press enter. S2, press enter. Not feed. Should be S2. Okay. And then the liquid outlet should be S3. The energy should be R duty. Okay. Once you type it, you can check on your flow sheet. We have S2 at the top, S3 at the bottoms. Okay, and then R duty as the energy fee. And then you can rename it instead of CRV hundreds. It's up to you how you want to rename it. If you don't want to rename it, leave it like that. It's also no problem. Or you can rename it as R1, reactors 1. It's up to you. Okay, so once you define for that, you can see the status bar at below there. Dimensions require a reaction set. So we are yet to define what type of reactions involved in these reactors. So we can click on the second tab on reactions. Under reactions, you can scroll down. We are selecting for set 1. since we only have one set of reactions, so yeah, the no other option for you to select. Okay, and then you can see at the bottom there they still have unknown duty, means they still do not know what is the energy you need to supply to your reactors. Either you supply energy to these reactors or you extract heat from the reactors. Okay, means either you act as endothermic reactions or exothermic reactions. So according to the questions given in class 5, you have to define the stream 2. So the temperatures for stream 2 should be equal to 25 degrees Celsius. So once you define the temperatures of stream S2, then you can see that the status bar here have turned into green colors with the OK sign. Okay, so yeah, there you have it. You've already fully defined the conversion reactors. Then we can move on to the next one, unit operations, which is distillation column. The unit operation they use to define for distillation column is called component splitter. Okay. Select component splitter and then paste it on your flow sheet. And then double click on that. They will lead you to another input box. Then follow the guideline, the step given in class 5. You can rename it as T1. The inlet should be S2. Overhead outlet is S4. You can type S4. And bottom outlet will be your product. So you type product. Energy stream is D duty. Okay. And the next step is they say they still have unknown split, but you can move on to the next step on parameters. Under parameters, you have to define the temperature for S4 and product. It's 25 degrees Celsius and 25 degrees Celsius. And select use lowest feed pressures for all products. Basically, you just follow exactly the same words being asked in the question set. And then next step, split here, we have to define the ratio. How many percent will you split into the stream of S4 or split into the stream of product? Okay. So in this case, we have to define for S4 is 1, 0, 1. Okay. Means we're defining the stream S4 should only contain species of HCl, ethylene, and nitrogens. So your product stream should only consist of products, means pure products. In this case, we are assuming it has 100% separations. Okay. So in this case, we only need to define for one S4. Then the software will automatically help you to calculate the balance of it. Means the value for product stream. Okay. So once you've defined for that, you can see the component splitter here now is turned into blue colors. Means all information required has been fulfilled. Okay. The next one should be your T, the stream splitter. So you search T, select the unit operation and paste it on your flow sheet. Okay. Double click on the split T. Okay, and then under the T, the inlet is S4. You have two outlets. Since there is a stream splitter, we will split into two streams. One is R, another one is W. Okay, R stands for recycle stream, W stands for waste stream. So now you still have a yellow warnings. Unknown split means you are yet to define 100% will go to R stream and 100% will go to W stream. So you click on the next tab on worksheet, and according to the questions, stream W should have a molar flow rate of 10 kmol per hour. So we define 10 for stream W. Then you can see the status bar here have been turned into pink colors. D1. D1. What do you mean by D1? Oh, you mean component splitter? Jeremy, you mean okay? Okay, for component splitter, okay, we can go back to what has been listed in your step 7 on the questions. So we change the name D1. We define the inlet as 2. We define the overhead outlet as 4. We define the bottom outlet's product. And we define the energy stream as D duty. Okay? So we define all the inlet and outlet we define all the inlet outlets for this component splitter. Okay. So next is parameters. Under parameters, we define for temperatures 25 for stream S4, 25 for product streams. Okay, all informations are given on the question set. Okay, so if you cannot follow, you can refer back to the question set. Third one is on the split. Split means what is the ratio will be flow to S4 and what is the ratio will flow to products. In this case, according to questions, they say stream S4, the value should be 1, 0, 1. Okay? It means HCl will move all the way in stream S4. It will not appear in your product stream. The same for ethylene and nitrogens. Then your product C2H5Cl only exit in your product stream. That's why you see 0 in S4 and 1 in product. Okay, so this section is for you to define the ratios. They're going to come out at your outlets. Okay? Once you define for this split, then close it. You should be able to see the colors of your component splitter has been turned into blue color. Okay. Then your next unit operation will be a T. So add a T unit equipments on your flow sheet, and then you define for the inlets and outlets. Okay. Your inlet is S4. Then the outlet will be stream R and stream W. R stands for recycle stream. W stands for waste stream.